Ladies and gentlemen, welcome back from a wonderful, wonderful fall break. If only we could have a fall break every week. Unfortunately, the world doesn't work that way. And fortunately, it gives us an excuse to learn some math. So, we are going to start your next unit. We're going to talk about these things called sequences and series, but we are really only going to worry about sequences today. So, today you're going to learn what the heck is a sequence, and then you're going to be able to tell the difference between arithmetic and geometric sequences. And you're going to say, hang on, Mr. Barton, you said that word kind of funny. Isn't that arithmetic? I've had this argument with hundreds, maybe even trillions of students. When I learned about arithmetic and geometric sequences, I learned about them in college. For whatever reason, when I was in high school, back when we had to walk uphill both ways in the snow, we had to ride our horse and buggy, we had to grind our wheat with stones. We didn't learn about this stuff in high school, but I learned about it in college. And my professor in college was Dr. Chen. And this dude was tight. He told us the greatest stories. One time, he told us the story about how he got the highest score out of anyone in his class at Johns Hopkins University. And if you've never heard of Johns Hopkins, neither had I. So that goes to show you how important that achievement is. But Dr. Chen, he was Chinese, as you might be able to tell from his name. And Dr. Chen had a very thick accent. So we didn't learn formulas. Well, how do you spell formulas? We learned formulars and stuff like that. But he had a really thick accent. So I'm not really sure if the way I say this is because you actually say it arithmetic, or if it's because Dr. Chen was really Chinese. It could be either. Here's my argument for why this is pronounced arithmetic and not arithmetic. This is an adjective, right? Arithmetic, the noun, is like adding, subtracting, multiplying, dividing. It's like what you learned in preschool, right? Plus, minus, the other operations, right? This is what your grandmother learned, and then they're like, cool, you're good with high school. Go out and get a job that pays really well and you can buy a whole house on it, even though you only have a high school education that's really only equivalent to today's elementary education. But, either way, this is a noun. Okay, this is a thing. You learn arithmetic. This is an adjective. And that's why I think they're different. But I digress. So you're going to learn some sequences, you're going to learn arithmetic, and you're going to learn geometric. So let's go learn some vocabulary first. So first you're going to say, Mr. Brown, what the heck is a sequence? It's got a Q in it, and if I know anything about words with Q's in them, they're usually too complicated and we should use a different word instead. So if you want to, you can think of a sequence as just a list of numbers. You don't even need any patterns. No patterns needed, and it doesn't even need to go on forever. So 1, 1, 2, 1, 13, 3.14. That's a sequence. It doesn't have any patterns. It doesn't go on forever. It's kind of just a boring list of random numbers, but that's a sequence. So sequences are just lists of numbers. Unfortunately, fortunately, you guys put a ton of points into luck, so you have good fortune. I'm not going to spell that. Ours will have patterns, because if they don't have patterns, they're kind of boring, and math is all about patterns anyway. So we will have patterns, and ours won't necessarily go on forever, but it's kind of implied that they do. We could make them go on forever if we felt like it, but we'll probably only look at like the first 10 or 20 or 180 or something easy, right? All right. So, Barton, quit goofing around. Tell me the important stuff. All right, so here's the difference between arithmetic and geometric sequences. An arithmetic sequence is a sequence where the difference between each number is the same. So what that means is you're just adding or subtracting the same amount every time. So pick your favorite number. That noise in the background, that's my dog lapping up water like a rude boy. But, you know, she'd die if she didn't, so we're going to forgive her. So pick your favorite number. 7. It's funny that you all said 7. All right, pick your second favorite number. Oh, 3. I'm glad you all agree. So if we just start at 7 and add 3 every time. So plus 3 would be 10, plus 3 more would be 13, plus 3 more would be 16, plus 3 more would be 19, and it could keep going forever. This is an example of an arithmetic sequence. Okay. So what other math operations do you know? Let's think about them. Subtracting. Okay, well, arithmetic is also subtracting. So we got that one covered. So we could start at 7 and do minus 3. So 4, 1. Oh no, there's nothing lower. Just kidding. -2, -5. Right, so you could subtract each time. So that's still arithmetic if you subtract. What other math operations do you know? Multiplying, Mr. Barton. Multiplying. Wonderful. So a geometric sequence is where the quotient of any two consecutive numbers is always the same. So that just means you're multiplying or dividing by the same amount every time to get the next number. So an example would be, let's start at 1. Let's start easy. And we'll do times 2. So 2 times 1 is 2. Times 2 is 4. Times 2 is 8. Times 2 is 16. And so on. This would be a geometric sequence because we're multiplying by the same thing every time. All right. 2 more words you've got to know, or rather 2 more vocabulary phrases. A common difference, that's the amount added or subtracted. Put or subtracted in an arithmetic sequence. So here, our common difference would be 3. D equals 3, because you went plus 3, plus 3, plus 3, and so on. Here, your common difference would be -3, because you're subtracting. So anytime you're subtracting, it's still the same number, it's just negative. Likewise, there's a special name for the thing that you do in a geometric sequence each time. The number that you're multiplying by is called the common ratio. So that's just the number that's multiplied each time. And then we'll talk about dividing and how you figure it out. So dividing is still a common ratio, but it'll be a fraction. I know. Your 3 greatest fears in life are commitment, disappointing your parents, being burned alive from the feet up in a volcano, lists that have the wrong labeled number of things in them, and fractions. All right, so let's look at some examples so that you guys don't go, Mr. Barton never teaches me anything. He just reads vocabulary words to me. So, arithmetic sequence example. This is exactly the phrase you're going to get in your homework. It's going to say, determine if the following list of numbers is arithmetic, and if so, find the common difference. So the first thing is it arithmetic? Yes or no? The second thing is, if yes, then we have to go figure out what is D. Okay? So we're going to look at our list of numbers, and we're going to figure out, are we adding or subtracting the same thing every time? So the way you can do that is you can just rhetorically ask yourself, what number do you add to 13 to get to 15? And most of the time you can figure it out. So it would be 2, right? You go plus 2. And then what do you add to 15 to get 17? Plus 2, plus 2, plus 2, plus 2. So we can see it is the same thing every single time. So we would say, yes, it's arithmetic. The common difference here is that number that you're adding each time. So D would equal 2. Cool. let's hypothetically say that that rhetorical question is too hard for you. On this next example. Okay. So we want to determine, is this one arithmetic or not? And if it is, what's the common difference? So what do you add to 5/4 to get to 1, right? And we're going to pretend, get it? We're pretending you don't know the answer because, you know, you're all geniuses. And of course you know. What kind of kid wouldn't know what you add to 5/4 to get to 1? So we're pretending you don't know. Some of you actually probably do, but some of you probably don't. So we'll pretend. So the way you find a common difference, if you have something goofy like this where it's fractions or it's just weird numbers that you're not really sure about, what you want to do is take the second number. Okay, I took it. It's over here now. And subtract the number before it. So 5/4. Okay. Type this thing into your calculator. Or you could be a big kid about it and just turn into a fraction and then do the subtraction. But put it in your calculator, and your calculator will tell you this is -1/4. Okay. Now we need to continue checking the rest of the sequence to make sure this rule still applies for the rest of the sequence. So we're going to take the next number, the third number, so 3/4, and we're going to subtract the number before it. So 4/4, that's a fancy way to write 1. So 3 minus 4 is -1/4. Ah, they match. Okay, but you can't just stop there because they like to make maybe like the second to last one or the last one be different. So you want to check every single set to make sure that it is consistent. So we'll take the last one, 1/2. We'll subtract the one before it. We'll type it into our calculator because we don't have a matching denominator, and it will still tell us -1/4. So because we get the same answer every single time, we know that this is an arithmetic sequence. The common difference, D, is this number that you just found over and over. This is the difference between those two numbers. So our common difference is -1/4. Good? Good, Mr. Barton. Cool. Good. Thanks, kids. All right. Last example for arithmetic. So we want to look at this list of numbers. 1, 11, 111, 1,111. Cool. So let's do that trick we just found. So we'll take the second number and subtract the number before it. So 11 minus 1 is 10. All right, let's do the next one. 111 minus 11. That's, let's see, minus 11. 1 minus 1 is 0. 1 minus 1 is 0. Bring down the 1. That's 100. Uh-oh. Do you see how these two numbers are different? That means we added a different number here. Here we added 10, and here we added 100. So because these numbers are different, this is not an arithmetic sequence. And then what's the common difference? This doesn't even apply because common differences go with arithmetic sequences. Because this isn't arithmetic, it doesn't have a common difference. All right, so I think you got a handle on that. Let's go look at a geometric sequence. So we want to determine if the following list of numbers is geometric now. And if it is, we want to find the common ratio. All right. So again, geometric means multiply by the same amount every single time. So what do you multiply 1 by to get 10? Times 10. What do you multiply 10 by to get 100? Times 10. What do you multiply 100 by to get 1,000? Times 10. So because we're multiplying by the same amount every single time, this is geometric. And our common ratio, R, is whatever this number we're multiplying by is. So 10. Okay. Let's look at this. Oh, excuse me. Pardon me. That's just my enthusiasm coming out. Sorry, it comes out in long, drawn-out gasps of air. So we want to determine if this is a geometric sequence. And we're going to ask ourselves, what do you multiply 144 by to get 72? And you're going to go, divide by 2. Okay, I didn't ask you what we divide by, though. I asked what we multiplied by. So you can't say divide by 2. That's not what I'm asking. I'm asking multiplying. So you have to tell me what to multiply by. So this is the point where I need to show you how do we figure out the common ratio or check the common ratio if we can't sit there and think about what do I multiply by. So just like for arithmetic sequences, we take the second number and then subtract the one before it. We're going to do the multiplication version of subtraction, or the converse of multiplying, or the inverse rather. I misspoke. So we're going to do dividing. Oh, you just said we can't shh. We're going to divide. So you take the second number, 72, and then you divide by the number before it, 144. So you reduce this fraction. It's 1 over 2. You can type that into a calculator and I'll tell you that, I promise. This thing will be our common ratio, but we need to just make sure that it's consistent for all of them. So next we're going to take 36 and we're going to divide by 72. Oh, look at that. It's 1/2. All right, one more time. We're going to take 18 and divide by 36. 1/2 again. Okay. So this is geometric because these numbers are the same every single time. And our common ratio is this fraction. It's 1/2. But Mr. Barton, how do I know if I'm dividing? Isn't there an easier way? Do I have to do it this way? All right, kid, let me tell you how to do it. If you are dividing every single time, since you guys are so keen on this dividing business and you're so terrified of fractions, I'll tell you the sissy way to do it. If you're dividing by 2, dividing by 2, dividing by 2, your common ratio is equal to 1 divided by whatever you're dividing by, 2. So if you're dividing, it's 1 over that number you're dividing by. And there you go. That is everything you need to know about geometric sequences and arithmetic sequences for the next 24 hours. Tomorrow, though, you're going to learn more, even more challenging, rigorous, fun thingies we can do with lists of numbers. Until then, have a wonderful day. Stay out of trouble. Tell your parents you love them. Don't do drugs. Make sure you get at least 30 minutes of exercise. Pet your pets. Clean your room. And, oh, don't forget to take out the chicken. Your mom's going to be mad if you have it frozen when she gets home.